Yeah, so the multiplying polynomials video crashed. So I'm going to try to just quickly recap just in case somebody's out there and wanting to review this. So when multiplying polynomials, we want to first of all expand. So whenever you see a bracket anywhere, um, you want to multiply, distribute out, right? So the way I show it to you, I know you might have heard of FOIL in grade 9 or your previous teacher might have used it. It's not wrong, but I feel like if you follow this method, it works for any configuration. Doesn't need to be a 2 by 2, right? So basically you start with the first term on the left here and you multiply by the first term on the other side, and you continue that for as many terms as you would have on the second bracket. So 5x times 4x, right? Like 5 times 4 is 20. X times x is x squared. And you go 5x times negative 1. Well, 5 times negative 1 is negative 5, and the x just tags along. Then you go over to your second term. You go 2 times 4x is 8x. 2 times negative 1 is negative 2. So you've expanded that here. And then you want to simplify. Simplifying means combining like terms. So if you have two x's or two xy's or two y's or more, whatever, you want to combine them all into just one. So here we have x squared only appears once, the negative 2 only appears once, but the x's right here, they're next to each other, they can be combined. So negative 5 and 8 gives you negative 5 and positive 8 is positive 3x. So that is your simplified version. So that gives you the full marks you need. And then we did some more examples here, right? Just 5x, just a one term multiplying across a bracket. There's a trinomial in there. It's just a specific name for that polynomial because it has three terms. So 5x distributes out, right? So just do that. And so 5x times 3x squared, 3 times 5 is 15, and x times x squared, you have 3 x's being multiplied, so that's x cubed. 5x times 2x, and it's all positive. 5 times 2 is 10. X times x is x squared. Next is 5x times 4, and that's just 5 times 4 is 20, and the x just tags along, right? And then we did, a 2 by 3 scenario. It's a bit more work, right? So it's 5x times 3x squared. That gives us, 15x cubed. 5x times 2x. 2 times 5 is 10. X times x is x squared. 5x times 4, that would be 5 times 4, that's 20, and the x just tags along. Then the next term I get by going 2 times 3x squared, that's 6x squared. 2 times 2x, that's 4x. 2 times 4 is 8. So now you have to expand it, you simplify, and you want to go in descending order. So x cubed goes first, and then you want to combine your x squares, 10 and 6, and then the 20 and the 4x, they come next. And then lastly, you want your number at the end. That's convention, okay? And then we moved on to D here. 3 is also a 2 by 3, and they're all positive. I think you get the picture there. I will not dwell on that one. I will spend my time on this one because you have some negatives here, so you have to be very careful there. So 3k times k squared, right? It's just 3, and k times k squared is k cubed. Then you have 3k times negative 2k. 3 times negative 2 is negative 6. Watch the sign. K times k is k squared, right? They both have a k. Then it's 3k times negative 7, which gives you a negative 21, and the k just tags along. You switch over to the second term and you distribute that to all the terms on the second bracket. So you go to 4 times k squared is positive 4 squared. 4 times negative 2k is negative 8k. And then 4 times negative 7 is negative 28. Okay. And then you try to arrange them in descending order. We combine like terms. So k cubed obviously is the leader. Then the k squared, there's a k squared there and a k squared there. Negative 4 and 6 is negative 2k squared. Then you have the k's, right? Negative 21 and negative 8 is negative 29k minus 28. You got that. And then here I had an example of multiple variables, right? So multiple variables, it still doesn't change anything. It just makes things a bit more challenging and you need to just watch out for it. So we do the same. 3x times 4x, 3 times 4 is 12, x times x is x squared. You move on, 3x times negative 3y, 3 times negative 3 is negative 9, x times y is just xy. Okay, moving on, 3x times 5, positive both, that's 15x. Now you're done with 3x distributing, then you move over to negative 2y. Don't forget the sign in front of it. Negative 2 times y, that is, times 4x, that's negative 2 times 4 is negative 8. And then it's yx, but we write xy because we already have an xy on this side. It's easier to identify that they're like terms. And then you go negative 2 times negative 3y, and they both have y, right? Negative and negative gives you a positive 6, and the y goes squared. Negative 2 times 5, negative 2y times 5, that's a negative 10, and the y just tags along. And then so that now you've expanded it, and the next step is to reduce it. So when we have two variables, you want the highest power of each variable on opposite ends, and then they kind of reduce until right in the middle you would have a combined xy. And this will look different the higher the powers are. So and anyhow you have 12x squared, then there's a negative xy and a negative 8xy here. So these xy's I'm going to combine, but first I'm going to go with the x. There's a 15x, I'm going to put that down. These combined give me negative 17xy. Then I have a negative 10y here and a 6y squared at the end. So you have this x squared here, y squared there. The y, right, goes down until you have xy in the middle, and then you go x and x squared towards the left. So that's convention. Okay, so there's that. And then we talked about some challenging cases, right, when you have a bracket to the power of 2. That does not mean, right, I have an example that you can just square the first term and square the second term and have it like this. You're missing, that will be wrong. Just rewrite that as, you know, bracket times bracket, right? And distribute out, just like you did before. Combine like terms, km combines, and this is your answer. This is wrong. It's missing that middle term. Okay. Next, we had examples. So you can always pause and fill in your notes if you haven't taken them yet. But something I needed to address is if you have a coefficient and a 1 is not written down, but you need to look at it as there being a negative 1 in front of this whole bracket. So a negative is really a negative 1, which needs to be distributed across the whole bracket. So this could have 3, 4, 5, as many terms as you can think of. That negative 1 affects every single term in that second bracket, in that bracket that is behind it. Okay, and also what can be said is that there's technically a positive 1 in front of this one, but we don't need to distribute it because it's not going to change anything, right? Only a negative 1 changes everything, changes the sign. Okay, So x plus 3 just comes down like this. The negative 1 distributes times 2x gives you negative 2x. Negative 1 times 1 is negative 1. These two, right, those are x's. You get a negative x out of that. And then 3 minus 1 is 2. And so that's your final expression simplified. Then you had I, which had each of the brackets had a coefficient in front of them. This had a positive 4. This bracket had a negative 3. So distributing, you get 4x plus 8y on this here, and then negative 3 times 3 is negative 9x, and then you have negative 3 times negative 2y. That would give you a positive 6y. Then you combine like terms. Your x's, right? 4 and negative 9 gives you negative 5. And then the 8 and the 6 give you 14y. So that's nice and combined. You don't have repeating terms anywhere. And the last one, the more challenging one, whenever you have two brackets multiplied, take care of that first, even though there might be a coefficient in front of it, like a negative 1 or a 2, 3, negative, whatever. Do the brackets first. Okay? So we do these two, we get that. And I put that in brackets so that I can kind of show you that this results to that. And then on this side, there was that 2. There could have been a negative 2, a negative 5, whatever. Do the brackets first, distribute that, you get this. If you want to combine like terms first and then distribute the 4 across, or sorry, the 2 across, that is fine. It's that I don't mind either way. It's probably less work if you want to combine like terms and then distribute the coefficient, that number in front of the bracket across. Anyhow, once you've done that, you combine like terms, right? This 12m and there was a 12m squared and a negative 12m squared, so you could cancel that out and so forth. All the m's, if you added them all up, you get 17m, and you got a negative 2 there and a negative 8, which gives you negative 10. And this was the homework. Some of it is correcting a mistake that somebody has made, which is somewhere in the higher numbers here, which is very important to know how to do. Other than that, that's it for this video. I hope it helped at least. It's not the full 1 hour that I had, or 45 minutes, but the other one crashed on me. So sometimes that happens. I hope this helps.